Good morning, guys. So this is finishing up Unit 5 notes, solving trigonometric equations. So just as we solved equations for a value of x that satisfied the equation, we do the same for trig equations. In this case, finding the value of an angle that satisfies the equation. So for example 1, sine x is equal to 1. So we can do this by inspection. We know from our knowledge of graphing and quadrant angles that the angle that satisfies this equation is 90 degrees or pi over 2 in radians. So again, what this is saying is where does this angle, sine of what angle is equal to 1? And that's where you would have to know your quadrant angles. Okay, so right, these are the quadrant angles, right? So this right here is 0 degrees, and its coordinates would be 1, 0. This up here is 0, 1. This over here, -1, 0. And this right here is 0, -1. And what it's saying is sine x, sine is the y coordinate. Where's the y coordinate 1 at? Well, right here would be, right here, the y coordinate's 1. So we would say that this right here is equal to 90 degrees. That's where that's coming from. However, there are other angles that satisfy this equation. If you go around again at 450 degrees, 450 degrees is also 1. If you go again, 810 degrees. If you go around, 3 times around, that's 810, that's still 1. So we usually solve the equation on a certain domain, saying it's from like 0 to 360 or something along those lines. Usually it's going to be when x is greater than or equal to 0 and less than 360, or the same thing in radians. So we can always verify solutions by graphing the equation. So we could graph these to kind of verify that is true. So our goal is to solve these trigonometric equations. But when you solve for a trig equation, it's not like isolating x. You just you must be able to look at it and then determine it by inspection what angle is represented by that. So with example 2 here, we're going to start by subtracting this 1. We want to isolate the trig function. That's going to be the goal in all of this, is to isolate the trig function. So just like before, our goal of solving equations, we would want to isolate the variable. Well, here we're isolating the trig function. So here we want to isolate sine x. So first thing, subtract 1. We got 2 sine x is equal to -1. From there, we would divide everything by 2 in order to isolate the trig function. So we have sine x is equal to -1/2. Now this is where you're going to have to do this by inspection, by looking at this and thinking about it, okay? If sine is the y coordinate, what angle has a y coordinate of -1/2? Well, if you think about the hand trick, okay, the hand trick, we're talking about the y coordinate. If you pull in 30 degrees, the y is 1/2, 1 over 2. But the thing here, it's going to be -1/2. So 30 degrees will not work. All right. So 30 is not going to work. You could write 30 because you know it's 1/2, but you know it's not going to be 30 because it's not negative there, it's positive. But this 30 degrees can kind of help you find the next angle. So think, what is the 30 has what reference angles? And again, this is going back to the special angles. Well, we know it's not going to be 30, 60, or 90. It's not going to be any of those, or I'm sorry, 30, 45, or 60. And then you go to the second quadrant. 120 is 60's reference angle. 135 is 45's angle. But 150 would be the reference angle. 30 is 150's reference angle. But think about this. All students take calculus. So 150 sine of 150 is 1/2 because it's the reference angle for 30, but it's still positive, so it's not negative. So the angle is going to be in the bottom two. Okay, it's going to so sine is equal to an angle that's equal to negative 1/2 somewhere in these bottom two, and it would be the angle that goes in that 30 goes into, that 60 and 45 doesn't. That would be 210 degrees. Okay, because right, 30 goes into 210, nothing else does. And then your other one would be 330. So this right here, x can be, or this angle here, theta, can be 210 or 330 degrees. Now, just to give you a reference here, I know we're not in class, but here's a unit circle. All right. So again, we isolated the trig function sine x, and we know sine x is equal to 1/2. Now, I prefer you use the hand trick to know all these angles here, but this is just a good visual guide for us to see. So we're trying to see, where is sine x equal to 1/2? Where is the y coordinate equal to 1/2? Well, we know that 30 degrees, that the y is 1/2, but it's positive. It's not negative. Going around here to 150, again, notice there that it's positive, not negative. But when you slip down here to 210, because that is a reference of 30, that's your negative, because all students take only tangent is positive here. So that is going to be a negative 1/2. And then likewise, at 330 degrees, it's going to be negative 1/2. Now, I'm showing you this unit circle just because I know I'm doing this by video, and it may be a little bit harder for you to see. So again, the goal of this is that, you're just trying to find where on the unit circle is these trig functions equal to this value over here. So really, you're using the unit circle, but of course, you're not going to have this unit circle on your test. You're going to have to be able to either, one, fill out a unit circle, and that would help you, or just kind of knowing the hand trick and knowing your reference angles. Okay, I don't mind. I will actually upload this into Canvas so you can kind of see it. All right, let's go to example 3. Now again, when we're looking at example 3, over here we wanted to isolate the trig function. Well, as you can see right here, this would be a quadratic equation because we have sine squared x and then just sine x. That's like saying x squared equals x. So you're not going to be able to isolate necessarily, you wouldn't be able to isolate the x here without doing some algebra. So same thing here. We're not really isolating the trig function here because we can't, just like we can't isolate x here. So what you're actually going to do here is you would solve this just the way you would solve this one. You need to move this sine x over here. So sine squared x minus sine x is equal to 0. Now you say, why are you doing that? Well, this is a quadratic equation. I solve this. I would solve this x squared equals x. And again, this is just an example, guys. An example of, without trig functions that I'm trying to show you. I'm going to solve this one. I do the same thing, x squared minus x. I'm solving this differently than I would solve like 2x plus 1 equals 4. I can isolate the variable there and find out what x is, but here, when you have a quadratic, an x squared with another x, you just can't isolate it because you'll never isolate the x. But what we would do from here and also from here is we want to factor something out. So we can factor a sine x out. And when I factor a sine x out of sine squared x minus sine x, I would be left with, there's still a sine x here, and then that would be minus 1 is equal to 0. Okay? Now this is the zero product property, just like with factoring, and this is what the zero product property says. If a times b is equal to 0, then a equals 0 and b equals 0. So we would say sine x is equal to 0 and sine x minus 1 is equal to 0. We're going to solve this one by adding the 1, and then here we are truly isolating the trig function once we get it to here. So these are our two possibilities here. These are our two factors for this quadratic right here. So what we want to do is just figure out where does sine x equal 0 and where does sine x equal 1. Now this is going to go into our quadrant angles because we know that 30, 60, and 90, all of those will be simply like, you know, the 1/2, the radical 3/2, the radical 2/2. So we're going to use these quadrant angles, what I drew out up here. Again, going back to Unit 2, I said, hey guys, we're going to use this. You need to know this. So where is the y-coordinate equal to 0 here? At 0 and 180 degrees. So x here can be equal to 0, 180 degrees, and then you got to come over to this one. It's just like a factor. Where does sine x equals 1? Where does the y appear? Where's the y-coordinate 1 at? Well, it would be at 90. So that would be comma 90 degrees. And this right here would be our answer. X can be 0, 180, or 90. All right. Now, I wanted to show you this just because it says we can always verify the solutions by graphing the equation. So this is the graph of these equations. If we manipulate our window just a little bit, so if we change our window, if we change the x-min to 0, going up by 90s, or no, sorry, let's go to like 360 because that's what our domain is on. 360, and they go up by 90s. We'll make the y-min -1. We'll make it the y1 1. And watch this graph. All right, now what I was trying to show you. I messed my window up, I'm sorry. Oh, okay. I'm sorry, I'm in radian, and I kind of made it degrees. So let me go to degrees. Sorry about that. I was like, man, what is going on there? But I made my window to reflect degrees. But here it is, here's the graph actually. So this is sine squared x, and wherever they intersect should be the points. Okay, so this is, if you're thinking about this, so watch this. So the blue is sine x or sine squared x, and the red is that. So wherever they hit is the solution, where they intersect. So they intersect right there at 0. They intersect up here at 90. They intersect right here at 180. And then, of course, they would intersect again at 360, which is the same as 0. But if you notice here, we said we're solving this with this, that it's not equal to 360, so we include the 0 and not the 360. So that's just kind of further evidence that 1, 2, 3 spots, and technically they do here as well, but we're only going to 360, but we don't include 360. And again, if I was to show you this, where is the y 0 and 1, and then the y is 1 right here, the y is 0, the y is 0, so 0, 90, and 180. Down here it's the y is -1, so obviously that's a little bit different. All right, let's come here to example 4. And again, the goal here is we just need to, so sine x equals cosine x. We're trying to figure out what can these angles be here. Where do they equal each other at? You can think about this in many ways. You can think, where does the x and the y equal each other at? And think about that. And if I was to show you this on a unit circle, where does the x and the y equal each other at? Because sine is x, cosine is y. So if thinking about this, look, right here at 45, the x and the y are the same. And down here at 225, the x and the y are the same. Nowhere else is the x and the y the same. So I automatically know that x can be 45 on both sides, and that's going to be equal. So sine of 45 and cosine of 45 is the same thing. So I automatically know that x is going to be 45 degrees and 225 degrees. I automatically know that. All right. But now if you had to work it out, obviously that's one way to work it out is just by inspection. But if you had to work it out, you could divide both sides by cosine x. Divide both sides by cosine x. That right side changes to 1 because cosine x over cosine x is 1. But sine x over cosine x is actually tangent x. And then you could ask yourself the same question, well, where is tangent x 1? And again, that would kind of, I see it better this way because it's when is x and the y equal to the same thing. But this is an algebraic way you could do it. Where's tangent x equal to 1? Well, that's going to be where basically y over x is the same. Y over the x is the same. Y over x, we're looking for that. Where is y over x the same? Okay, so again, that goes to tangent x is 1 because think about this on the hand trick. Radical 2 over 2 over radical 2 over 2 is 1. So that'd be 45 and 225 because tangent would be positive. All students take. So it's positive in the first and the third quadrant. So again, that gives me that right there. All right. Slipping over here to this 2 sine squared x equals 1. First thing we want to do is isolate that sine squared x. I'm left with sine squared x is equal to 1/2. Now, in order to determine, this is sine squared x, not just sine x, where sine x is 1/2. So we need to square root this. And what I do to one side, I have to do to the other. The square root and the square cancel. And that gives me sine x is equal to the square root of 1 over 2. Or it's really this plus or minus the square root of 1 over the square root of 2. Because I can rewrite that. If it's the whole thing, I can rewrite in the numerator and denominator. And then technically, I could really say plus or minus 1 over radical 2. So what we're looking for here is where is x, where is the y coordinate, this right here. Now again, this looks a little bit confusing to us, but I'm going to rewrite one more time because we're not used to seeing this right here. We're not used to seeing that denominator, that radical in the denominator. So I'm going to multiply top and bottom by radical 2, and that actually gives me radical 2 over 2. So now, but that plus and minus are still there. So we're really saying what angle has negative radical 2 over 2 and positive radical 2 over 2. So what angle has a y coordinate, because sine x is equal to plus or minus this, we kind of had to do some simplification here. What angle gives me a negative, what angle gives me the y coordinate of negative radical 2 over 2 and positive radical 2 over 2? So if you think about this, if I use the hand trick, I pull in 45, the y is radical 2 over 2. Well, that's positive radical 2 over 2. That's what we're looking for. So 45 is going to be 1. 45 degrees will be one of those. But then think about this. If you go to the second quadrant, that's 135. And 135 is the same as 45. Radical 2 over 2. And we know sine is still positive over there, so that's going to work. We go to the third quadrant, that's 225, which 45 goes into, and it's negative radical 2 over 2, but we're looking for negative radical 2 over 2 and positive radical 2 over 2. So 225 is going to work, and kind of by inspection here, you should kind of understand that 315 will work too, just because it's going to be the same thing, negative radical 2 over 2. So that would be all of our answers there. Now, if I show you the unit circle here, again, we're looking for where the y, where sine x is equal to negative radical 2 over 2 and radical 2 over 2. So notice right here, radical 2 over 2, it's positive, 45. Radical 2 over 2, 135. Negative radical 2 over 2, 225. And the y right here, negative radical 2 over 2, and again, 315. So that's just kind of, looking at the unit circle side of it. I don't think you need the unit circle, but again, with this being a video, I'm trying to give you a little bit more perspective here. Okay, slipping down here to example 6, it kind of creates its own kind of thing. And this, we haven't seen a lot of equations like this, trigonometric equations. But guys, you're actually going to work this just like you would. This is a quadratic. So think about this. This is almost like reading this as 2x squared minus 5x plus 2. Now, that's a quadratic equation, and if I ask you to solve that for me, if I said, hey, solve this for me and tell me what x is, you would have to factor that. All right? Well, we're going to do the same thing here, even though it's trig functions. So when you factored this in Algebra 2, we said, what's a times c? So what's a times c here? A times c is 4. What multiplies to be 4 but adds to be negative 5? Well, that would be negative 4 and negative 1. Negative 4 times negative 1 is positive 4, and negative 4 minus 1 is negative 5. Since 2 is not 1 there, we just can't say, like x minus 4, x minus 1. We have to rewrite the middle term. So factor by grouping here. So we'd have 2 sine squared x minus 4 sine x minus 1 sine x plus 2 equals 0. So what we just did here was we rewrote this middle term. We didn't change the value of the problem. We brought 2 sine squared x down. We brought 2 down. We brought the 0 down, and we just rewrote negative 5 sine x as negative 4 sine x minus 1 sine x. This is called factor by grouping. So you factor this side, you factor that side. What can I pull out of this? Well, I can pull a 2 out of the 2 and the 4, and a sine out of sine squared x and sine x. So I can pull a 2 sine x out. When I pull a 2 sine x out of 2 sine squared x, I'm left with a sine x. When I pull a 2 sine x out of negative 4 sine x, I'm left with a minus 2. Here, what can I pull out of negative 1 sine x and 2? Well, they don't have anything in common, so you always just bring this sign down, and you always bring down a 1. If you can't factor anything out, factor out a 1. If I factor out a negative 1, I'm left with sine x. 2 divided by negative 1 would be negative 2. Same thing here, guys, that we would have done. We bring these two together, just like we did with factoring. 2 sine x minus 1, and then sine x, and then just drop one of these down, sine x minus 2. This is just standard of factoring, guys. Not doing any tricks here. This is just plain factoring, but just with trig functions. Now, here's what the zero product property says of factoring, that if a times b is equal to 0, then a equals 0 and b equals 0. So we need to write this as 2 sine x minus 1 equals 0, and sine x minus 2 is equal to 0. So, and then we solve each one of these individually, and then we determine our x's. So add 1 to both sides. That's 2 sine x equals 1. Divide both sides by 2. Sine x is equal to 1/2. Over here, you would add 2 to both sides in order to isolate sine x. So we're isolating the trig function just like I said up here in the beginning, but we do it after we factor. So sine x is equal to 2. Now, because we know the trig functions and we know that sine never goes above 1 or below -1. So this right here, that's no solution. There is no angle that you are ever going to type into your calculator, sine something, it's going to give you 2. Okay? Sine stays, think about that wave. That sine stays between 1 and -1. Now, where is the sine x on the unit circle? 1/2. So where is the y coordinate 1/2? Well, positive 1/2, we know 30 is going to be 1. And where else is sine positive? It's going to be the multiple of 30, and that would be 150. Again, you need to have the ability to do this in your head. You do have your unit circle, and you could always confirm that 30 is 1/2, and then 150 is 1/2 as well. All right, so that is that. And guys, if you're sitting there saying like, man, how do I check myself? Again, we could check using the calculator, right? Or just simply going to your calculator. This one may be a little bit different, just because that whole sine squared x there. But we could type this in. I'm going to try to type it in. I won't try to mess it up. But sine x, but x here, we're going to say 30 degrees. I'm in degree mode. And then, of course, that's squared. So 2 times sine of 30 squared. I'm using this just to show that this should equal 0. Minus 5 sine of 30 degrees. And then plus 2. Now, if I type this in correctly, this should produce 0, because what we're saying is, what is x? What satisfies this equation? We put in the degree just like we would when we were solving something simple like this. When you isolate the variable, plug it back in to see if it works. So this should work here, and as you see, we get 0. I could do the same one, and what other angle should work in there? 150. So if I change here and insert 150, and then I come over here and I change this to 150, that also should give me 0. And then you're saying, well, hey, why won't anything work? Well, those are the only 2 x values that work in this equation. If you're saying, well, prove it to us. Well, let's say if this is 100, let's use 135. That's on the unit circle, 135. And if we see this, we see that it's not equal to 0. So these 2 angles are the only angles that satisfy this equation. Hope this is making sense. Let's flip over to example number 7. We have 2 cosine squared x minus cosine x equals 1. So again, guys, this would look just like this in terms of just pure x. So 2x squared minus x equals 1. So if you had something like this, give me 1 second. Hey, buddy. So if you have something like this right here, you would subtract the 1, and this is a quadratic equation. You'd factor it from there. So we have this. We would have 2 cosine squared x minus cosine x minus 1 is equal to 0. So we subtract that over because now this sets up a quadratic equation. This quadratic equation, we multiply a times c and get -2. What multiplies to be 2 but adds to be -1? Well, that would be -2 and +1. So since that's not a, we have to write this as 2 cosine squared x minus 2 cosine x plus cosine x, that's the 1 there, minus 1 equals 0. Now again, notice what we've done. We've just rewritten that middle term. We've rewritten it as negative 2 cosine plus cosine, and that truly is that. If you go from here to there, you go right back. We brought that down, we brought that down, we used our factoring rules to get this. Now we factor by grouping. What can I pull out of 2 and 2? Well, I can pull a 2 out. What can I pull out of cosine squared x and cosine x? I can pull a cosine x out. And then if I pull a 2 cosine x out of 2 cosine squared x, I'm left with cosine x. And always remember that if you distribute it, it goes right back there. And that's a good way to check to see if you're right. And then what happens when I pull a 2 cosine x out of negative 2 cosine x? I'd be left with minus 1. Here I'm doing the same thing. There's nothing I can pull out. They don't have anything in common, so I pull out a plus 1. And then I'm going to be left with the same thing, cosine x minus 1. And that, of course, that's equal to 0. I then bring everything together, 2 cosine x plus 1, and then cosine x minus 1 equals 0. I solve for this one, the zero product property, cosine x plus 1 equals 0. That's going to give us cosine x is equal to negative 1/2 once you subtract 1 and divide by 2. Just trying to save my room here. And then over here, cosine x minus 1 is equal to 0. That's going to be cosine x is equal to 1. Now, cosine, this is our first cosine problem. Cosine is the x-coordinate. Well, I guess we had cosine up here. But cosine is the x-coordinate. So now we're trying to figure out where is the x. Now, if you do it with this hand trick, this is going to tell you where everything else is, and you just need to know all students take calculus. So, where is the x? Negative 1/2. Well, that would be right here at 60 degrees. But in the first quadrant, 60 degrees doesn't work because cosine is positive. So that's where you got to know all students take calculus. So then just ask yourself the reference points of 60. Well, 60 is not going to work because it's positive 1/2 at 60 degrees. It's positive 1/2. But cosine in the second is negative, so we know that 120 is going to work here. 120 will work. And then go to the third quadrant. What's 60 go into for the third quadrant? Well, that would be 240. Double that, right? 240. And then what's the 60 into the last quadrant? And that would be 300. But 300 is not negative because cosine is positive in the fourth quadrant. So that's that. And where is cosine x? Where is cosine x equal to 1? Again, going back to this right here, guys. Where is the x-coordinate 1 at? And it would be 0. So x can be any of these things right here. And it's going to satisfy the equation. All right, got two more problems. Over here, sine x minus 1 is equal to cosine x. Now again here, guys, this is where it gets a little bit tricky because obviously we can't, again, there's numerous ways to work equations. And it's just totally kind of up to you. But this would be my advice for this one. This one kind of creates something a little bit difficult. So it's a little bit challenging, but you can handle it. And what you just need to do here, because there's not much we can do here. We can't, if we divide everything by cosine, we could split it up and get tangent minus secant, but that's really not going to equal 0. But that's really not going to do us anything here. So this is where you got to get a little bit of creative and just say, okay, what if we square both sides? So what if we square both sides? And again, why are we squaring it? Because we can't really do anything with the problem. If we add 1 over here, it doesn't give us any kind of identity or anything like that. So there's really nothing to do so most of the time. But what we do know we can do is that when we square both sides, then that starts creating some identity. So that's where the square's coming from. So this right here, if you were to FOIL this, that's sine x minus 1 times sine x minus 1. If you FOIL that, you're going to get sine squared x first, And then the outside and then the inside would be minus 2 sine x. Again, I'm doing 2 steps in one there. And then negative 1 times negative 1 is positive 1. So that's that. And then that's going to be equal to cosine squared x. Now we know a little bit something about cosine squared x. Cosine squared x, so I'm going to rewrite this as sine squared x minus 2 sine x plus 1 is equal to, we know that's actually equal to 1 minus sine squared x. That's a Pythagorean identity. And that's what we're wanting to do there, guys. That's exactly what we want to do. We want to get rid of, we want to get it to kind of like one trig function. So take care of that cosine, and that's going to lead us to sine. Now we can start combining like terms here. So if I add this sine squared x to both sides, and I subtract the 1, it's going to get me 0 on this side. And over here I'm going to have 2 sine of 2 sine squared x. Sorry, that kind of looks like a 2x. And then right here, that's going to remain the same. And then 1 minus 1 is 0, so we don't have to write plus 0 there. Now we have this. This is looking a lot better than this up here because here we had 2 trig functions. Can't really divide to get tangent or anything. So now we can factor this. This is just like this right up here, guys. That's exactly what we're dealing with. But we just have some 2's out there. So let's factor out a 2 sine x. That's what we can pull out of both of them. When we do that, we're left with sine x minus 1 is equal to 0. And then from there, the zero product property, guys. 2 sine x is equal to 0. And sine x minus 1 is equal to 0. That's going to come out to be sine x is equal to 1. And that, once you divide both sides by 2, you get sine x is equal to 0. So where's the y-coordinate on the unit circle? What angles has a y-coordinate of 0 and a y-coordinate of 1? Well, the ones that have a y-coordinate of 0 would be 0 and 180. So this one is going to be 0 and 180 degrees. And this one, where is the y1? That would be up at the top at 90 degrees. Again, we could, kind of look at the unit circle, 90, 0. They have zeros. The y-coordinates there are 0. And up here, the y-coordinate's 1. So that's kind of us. That's kind of confirming that. Then with example 9, I have sine of 2x equals 0. So something should jump out to you and say, hey, this is sine of a double angle. Okay? There is a difference in sine squared x and sine 2x. This represents the whole thing is squared. This represents a double angle. So that's where we have to know that double angle formula, which is 2 sine x cosine x equals 0. Now we divide everything by 2. We're going to get sine x cosine x equals 0. The zero product property says if a times b is equal to 0, then a is equal to 0 and b is equal to 0. So where is the y-coordinate 0 at? Well, we just kind of discussed that. That was the y-coordinate is 0 and 180. And where is the x-coordinate 0? Well, that would be at 90 and 270. Okay? And again, where is the y-coordinate 0? 0 and 180. Where's the x-coordinate 0? 90 and 270. And that completes that, guys. Hope this kind of making some sense for you. If you have any questions, feel free to reach out to me. Make sure you do your homework. It's due tomorrow at midnight. Okay, tomorrow at midnight. Make sure you get that done. Thanks so much.